are. Oh my gosh. Even if you look at it now, even when I look at it now, I still can't believe it, even though my brain tells me it's fine. So, watch me erase parts of the image and sort of see when you're able to break free of that illusion and be able to see the box A and B as the same color. This optical illusion is basically saying that the area labeled A is a darker color than the area labeled B. The image is basically a checkerboard with light and dark squares, partly shadowed by a cylinder that we see. Now, do you see it? Now, no, it's okay. Let's keep continuing with the erasing and let's see when you have your eureka moment. This illusion exploits the mechanism underlying something called the lightness constancy. That's basically our capacity to perceive the lightness or reflectance of a surface as an invariant, even when the intensity of the incident light, which is the illuminance, is changing at a point or is variable across the surface. Now, let me know when you're able to see the colors change to become equal. For me, I actually see the color change around here when that shadow depiction is over, and oh gosh, can you see? The two colors look the same to me. But what about now? Are you able to see checkered A and checkered B as the same colors? If not, it's alright. Let's do the final step of removing the shape next to these two checkers. And once we're done with that, we can remove the letters in the middle and sort of a touch up on the sides and top, bottom. They look like they're the same color. So strange. Did you get this right or wrong from the beginning? Just to verify that this isn't some kind of trick, I'll erase everything that we marked in, and boom, A and B. It looks darker again. But the third illusion that also tricks my brain immensely, the Poggendorff Illusion. The Poggendorff Illusion. Does the black meet the red or the blue? Does A meet B or C? Who thinks it's B, the blue line? And who thinks it's C, the red line? Well, let's see what the correct answer is. This illusion is another geometrical optical illusion that involves the misperception of the position of one segment of a transverse line that has been interrupted by the contour of an intervening structure. Oh gosh. The answer was C, and I know you can't believe it still, but look. That is a straight line. So, now going on to the last item before the Impossible indecipherable figure, actually. And it's a kind of an optical illusion. This optical illusion would appear to have 3 cylindrical prongs at one end, which then mysteriously transform into 2 rectangular prongs at the other end. So, are your brain and eyes getting tricked? Okay, number 5, the last one for today. Count the black dots. Look carefully at this image and count the black dots that you can see on the grid. Did you notice that when you focus on a single dot it turns white and the black dots appear around your area of focus?